determine the full load amperage of a 30 kvolt-amps uninterruptible power supply, or UPS, operating at 480 volts, we'll use a fundamental electrical formula. This formula relates kvolt-amps, voltage, and amperage. Specifically, the formula is full load amps equals kvolt-amps divided by voltage. In this scenario, we have a 30 kvolt-amps UPS operating at 480 volts. Therefore, the calculation is full load amps equals 30 kvolt-amps divided by 480 volts. Performing this division, we find that the full load amps equals 62.5 amps. Thus, the full load of the UPS is 62.5 amps. Now, let's address the overcurrent device size. According to the National Electrical Code, or NEC, the overcurrent device, often a circuit breaker, should be sized at 125% of the full load current. This is to protect the equipment from overloads and short circuits. To calculate the breaker size, we multiply the full load amps by 125%, expressed as 1.25. Therefore, the breaker size equals full load amps times 1.25. Substituting the value we calculated earlier, breaker size equals 62.5 amps times 1.25. This calculation results in a breaker size of 78.13 amps. In practice, circuit breakers are available in standard sizes. The next standard size breaker above 78.13 amps is typically an 80 amp breaker. Therefore, an 80 amp breaker would be an appropriate choice for this application based on the NEC requirement of 125% of the full load current. It is important to always consult the NEC for the most up-to-date requirements, as codes and standards can change. While the NEC provides a baseline for safety and code compliance, manufacturers often provide additional recommendations. In this case, the manufacturer recommends limiting the UPS load to 80%. It is important to understand the implications of this recommendation. If the manufacturer's documentation states an output of 36 amps with the 80% limitation already factored in, then sizing the overcurrent protection at 125% of that value is appropriate. In general, if the manufacturer says to load the UPS no more than 80%, then the output amperage already reflects this limitation. In that situation, the breaker is sized to protect the conductors and equipment based on that reduced value. However, it is essential to carefully examine the manufacturer's specifications and documentation. If the manufacturer states that the UPS is rated for 62.5 amps, but recommends limiting the load to 80% for optimal performance and longevity, then the overcurrent protection should still be based on the full 62.5 amp rating, in accordance with the NEC. The 80% loading recommendation is a guideline for operational efficiency, not a reduction in the equipment's rated capacity for overcurrent protection purposes. To reiterate, the full load amperage of the 30 kvolt-amps UPS at 480 volts is 62.5 amps. Based on the NEC guidelines, the overcurrent device should be sized at 125% of the full load current, resulting in a calculated value of 78.13 amps and a practical selection of an 80 amp breaker. If, and only if, the manufacturer's specified output already includes the 80% limitation, then sizing the breaker at 125% of that reduced output is acceptable. Always prioritize the NEC guidelines for overcurrent protection and carefully review the manufacturer's documentation to understand how their recommendations interplay with code requirements. If there's any ambiguity, it is best to err on the side of caution and adhere to the more conservative approach, which typically means using the full load amperage for overcurrent protection calculations. Also, consider reaching out to the manufacturer directly if there are some questions. If the manufacturer states that the 36 amps is the maximum continuous output with the 80% limitation already applied, then you can use this value to size the breaker. Remember to always consult the relevant electrical codes and the manufacturer's specifications for the most accurate and safe installation practices. Finally, ensure that all work is performed by qualified personnel who are familiar with electrical safety procedures and code requirements. To summarize, firstly, calculate the full load amperage of the UPS using the formula kvolt-amps divided by volts, which in this case is 30 kvolt-amps divided by 480 volts, resulting in 62.5 amps. Secondly, determine the overcurrent device size based on the NEC requirement of 125% of the full load current, which is 62.5 amps times 1.25, giving you 78.13 amps, and then select the next standard breaker size, which is typically 80 amps. Thirdly, understand the manufacturer's recommendations regarding load limitations, and if the output amperage provided by the manufacturer already factors in this limitation, then size the breaker accordingly, but always prioritize NEC guidelines and err on the side of caution. It's important to consider the specific context of the manufacturer's 80% loading recommendation. The recommendation is intended to prolong the life of the UPS and ensure reliable operation. This is especially relevant in applications where the UPS is subjected to frequent or prolonged periods of high load. By limiting the load to 80%, the UPS operates with a greater margin of safety, reducing stress on its components and minimizing the risk of failure. Furthermore, the 80% loading recommendation can help to improve the overall efficiency of the UPS. When operating at lower loads, the UPS typically consumes less power, resulting in lower energy costs and reduced heat generation. This can also contribute to a longer lifespan for the UPS and its components. In some cases, the manufacturer may provide specific Darting curves for the UPS, which show how the maximum allowable load varies with ambient temperature. It's important to consult these Darting curves to ensure that the UPS is operating within its safe operating limits. Ignoring the manufacturer's recommendations can lead to premature failure of the UPS, resulting in downtime, repair costs, and potential safety hazards. It's also important to note that the 80% loading recommendation is not always applicable. In some applications, such as those involving critical loads that must be supported at all times, it may be necessary to operate the UPS at or near its full rated capacity. In these cases, it's even more important to ensure that the UPS is properly sized and that the overcurrent protection is adequate. Furthermore, it's important to consider the type of load that the UPS is supporting. Some loads, such as those with high inrush currents, may require a larger UPS than would be indicated by the steady-state power requirements. Inrush current is the peak current drawn by a device when it is first turned on. It can be significantly higher than the normal operating current. The UPS must be able to handle this inrush current without tripping the overcurrent protection or causing a voltage sag. Voltage sag is a temporary reduction in voltage. It can cause sensitive electronic equipment to malfunction or shut down. To address inrush current, it may be necessary to use a UPS with a higher kvolt-amps rating or to install soft start devices on the loads. Soft start devices gradually increase the voltage applied to the load, reducing the inrush current. In addition to the NEC and the manufacturer's recommendations, there may be other applicable standards and regulations that must be considered. For example, some jurisdictions may have specific requirements for UPS installations in healthcare facilities or other critical applications. It's important to be aware of all applicable requirements and to ensure that the UPS installation complies with them. In summary, calculating the full load amperage of a UPS and sizing the overcurrent protection requires careful consideration of several factors, including the UPS kvolt-amps rating, the operating voltage, the NEC guidelines, the manufacturer's recommendations, the type of load being supported, and any other applicable standards and regulations. By following these guidelines, it's possible to ensure that the UPS is properly protected and that it will provide reliable power to the critical loads it is supporting. Remember that electrical codes and standards are subject to change, so it's essential to stay up to date on the latest requirements. Consult with a qualified electrical engineer or electrician to ensure that the UPS installation complies with all applicable codes and standards. The NEC, in particular Article 408, covers switchboards, switchgear, and panel boards. Article 408.36, Overcurrent protection, specifically addresses the requirements for overcurrent protection of panel boards. This section requires that panel boards be protected by an overcurrent device having a rating not greater than that for which the panel board is designed. In the case of a UPS, the panel board that distributes power from the UPS should be protected by an overcurrent device sized according to the UPS manufacturer's specifications and the NEC guidelines. The overcurrent device should be located at the point where the UPS output conductors connect to the panel board. Furthermore, Article 110.3 Examination, Identification, Installation and Use of Equipment states that equipment must be installed and used in accordance with any instructions included in the listing or labeling. This means that the UPS must be installed and used in accordance with the manufacturer's instructions, including any recommendations for overcurrent protection. Ignoring the manufacturer's instructions can void the warranty and may result in unsafe operating conditions. One aspect that's important to consider in UPS sizing and overcurrent protection is the short-circuit current rating, or SCCR, of the equipment. The SCCR is the maximum fault current that the equipment can safely withstand without causing a fire or other hazard. The UPS, the panel board, and all other components in the system must have an SCCR that is equal to or greater than the available fault current at the point of installation. The available fault current is the maximum current that can flow in the event of a short circuit. It is determined by the impedance of the power source and the conductors. Calculating the available fault current requires detailed knowledge of the electrical system. It's typically done by a qualified electrical engineer or electrician. If the SCCR of the equipment is less than the available fault current, then additional overcurrent protection, such as current-limiting fuses, may be required to protect the equipment. Current-limiting fuses are designed to quickly interrupt high fault currents, limiting the amount of energy that flows into the equipment. They are often used in applications where the available fault current is high, such as in industrial facilities. It is extremely important to ensure all the components have the correct SCCR, or short-circuit current rating. To summarize the key steps, firstly, determine the UPS full load amperage by dividing the kvolt-amps rating by the voltage. Secondly, size the overcurrent protection device at 125% of the full load amperage, in accordance with NEC guidelines. Thirdly, adhere to the manufacturer's recommendations regarding load limitations and overcurrent protection. Fourthly, verify that the SCCR of all equipment is equal to or greater than the available fault current. Finally, ensure that all work is performed by qualified personnel who are familiar with electrical safety procedures and code requirements. By following these steps, you can ensure that the UPS is properly sized, protected, and installed, providing reliable power to your critical loads. Keep in mind that the specific requirements for UPS installations can vary depending on the application, the location, and the applicable codes and standards. It's essential to consult with qualified professionals to ensure that the installation meets all applicable requirements.